So we attempt to prove, if you are given a circle, say APB with center O, circle APB with center O. So what are we trying to prove? So we are given a circle APB with center O, with center O. We're trying to prove that AOB is equal to 2 times APB. We said AOB is equal to 2 times APB. So we have that to prove that AOB is equals to 2 times APB. AOB is equals to 2 times APB. So the first thing we'll do a minor construction. We'll do a construction in that construction we simply join PO and produce it to any point Q. Join PO and produce to any point Q. So we are joining P here to point O here. I will produce it to any point Q. So I have a line from this point passing through O to any point Q. Having done that, we're going to do some numbering. We discover that AOP is an isosceles triangle because OA is essentially equals to OP, because we said that a line drawn from the center of the circle to any part of the circumference is the radius. So if these two lines here are equal to each other, it therefore follows that angle AOP is an isosceles triangle, because we said an isosceles triangle, two sides must be equal. For a triangle that has two sides equal, we refer to it as an isosceles triangle. So in that case, we are going to know that even BOP also is also an isosceles triangle, because OP is equals to OB. So both of them are two similar isosceles triangles. But we'll focus on AOP for this proof. So if we refer to this as, say, x2, that angle there as x2, for clarity's sake I'll bring it as x2. We have an angle here, we have an angle here. I'll refer to this as x1. This angle here is y2, and refer to this as y1, the angle here. I haven't done that with this numbering and focusing on AOP as an isosceles triangle. We are going to first of all establish the fact that OA is equal to OP. So we are saying that OA is equal to OP. So that's the case. That simply means that this angle here, the base angle here, this angle here, and this angle here are the same. That is to say, x1 is equal to x2. So I have that we can also say that the reason for this is the fact that the radii, if I explain that, the radius of the circle. So therefore, x1 is equal to x2. So that means the base angle of an isosceles triangle, because we said the base angle of an isosceles triangle is actually the same. So what we mean by that is if I have a triangle, say ABC, and if these angles, we have different angles here, if AB is equals to AC, that means these two base angles, they are the same. So that's why x1 is equals to x2. So we can say x1 is equal to x2. So the reason for that is the base angle so we can also say that, I'm going to establish that fact, that angle AOQ is equal to x1 plus x2. And what's the reason for that? So this is AOQ, this angle here. It said it's equals to x1 plus x2, because we have that the exterior angle of the triangle is equal to the sum of the opposite interior angle. That means this angle here is equal to the sum of this angle here plus this angle. That is the sum of the opposite interior angle. Exterior angle is equal to the sum of the opposite interior angles. So that in that case, you can also put that down. So having established that fact, we know that x1 is equal to x2. So we have that x1 is equal to x2, so that AOQ is equal to x2 plus x2, since we said x1 is equal to x2. So in that case, I have that AOQ is equal to 2x2. So similarly, we know that BOQ is similar to AOQ. So I have B, similarly, BOQ is equal to 2y2. If we follow the same principle, focusing on BOQ. So that we also realize that AOB, the center of the circle, AOB is equal to AOQ plus BOQ. AOB is equals to AOQ plus BOQ from the diagram. So in that case, I simply have that AOB is equals to AOQ, which is 2x2 here, plus BOQ, which is 2y2. So in that case, we have that AOB is equals to, we can factorize 2r, so I have that x2 plus y2. So I haven't gotten that x2 plus y2. And what is x2 plus y2? We'll look at our diagram. We see that this is x2 and this is y2. So x2 combined with y2 here is simply a, p, b. So x2 here and y2 is a, p, b. So that I have that a OB is equal to 2 times APB, which proves that angle at the center is twice angle at the circumference. So we have been able to prove that angle at the center AOB is equal to 2 times APB.